Okay, so let's work through this problem as quick as I can. Try and write pretty small. Hopefully you can see it. So I'll give the balanced molecular reaction. That's the whole thing. So I have NaI plus, I did that, but well, PbNO3 2. That goes to PbI2, and that'll be solid. We should know by now that pretty much lead is in every precipitate. I shouldn't say that, but everyone we've done lately has, if it has lead in it, it's in the precipitate. And then we're left with NaNO3, which would be aqueous, which we should know because Na and NO3 never do form a precipitate. So we'll go ahead and balance it. You have two I's right here. So you better put a 2, which makes a 2 here, which makes two NO3s, which is what you needed. So that looks good so far. The net ionic equation, that's where we just take the things that make that. So it took 2I minus plus Pb plus 2 to make PbI2 solid. Sorry, that's supposed to be lower, but oh well. All right, so hopefully that's not too difficult so far. All right, so now how many moles of each species are present? So I'm going to take advantage of this space up here. So I have this and that of NaI. So NaI, and I'm going to say that it is 0.300 liters times 0.500 molar. That ends up to be 0.150 moles. And that's true for Na plus, and it's true for I minus. All right, so that works for both of those. Then we'll do the same thing for PbNO3 All right, and we will have 0.500 liters times 0.200 molar. That is equal to 0.100 moles of Pb plus 2. But remember, since there's a 2 right here, our NO3 minus will be double this, so 0.200 moles NO3. Hopefully that makes sense. All right, just had to pause for a second there. All right, so those are the 4 answers. We'll use those coming up pretty soon. So that was actually the answer to this problem. Then it says, what is the total volume of the solution? All right, Slate stopped working for a second. The total volume of the solution is just the addition of the 2 liters. So it's 0.300 liters plus 0.500 liters. So the total volume is 0.800 liters. If you're annoyed that I keep doing the 0 zeros, that's because I'm trying to make sure that I stick with our significant figures. All right, what is the limiting reactant, and justify your answer? Okay, the limiting reactant, I have to come up, oh, I erased it. 1 second. All right, so I rewrote this reaction again. So the limiting reactant, we have to look at our moles present. So if you remember, we had 0.150 moles of the first thing and 0.15 or 10 moles of here. So 0.150 here and 0.1 here. All right, if you notice, it is required that we have twice the amount of Na as we do Pb. So I come up here and I say to myself, is this number 2 times bigger than that number? The answer is no, so that means this number must be the one that runs out first. So NaI will be my limiting reactant. All right, I'll put that down here. So this is my limiting reactant. That must mean this is my excess reactant. And I'm going to go ahead and say this is my precipitate, and then I might as well just say this is my spec ions. All right, so once again, I said this is the limiting reactant, and the reasoning why is because the amount of moles I have of it is not 2 times the amount of moles that I have that. All right. Then it asks, what would the mass of the precipitate be? I have this written down somewhere. I think it's 461, but just in case. All right, so yeah, I did look it up. The molar mass of this is 461.01 grams using my periodic table, and that's PbI2 per 1 mole. All right, so I'm going to set up a picket fence here. Oh, crap. Let me try that again. All right, and in this picket fence, I'm going to solve for, such a pain, the grams of PbI2. I'm going to start with my limiting reactant, which I said was NaI. Scrolling up here, once again, the moles of NaI were 0.150. All right, and then 2 moles NaI, that came from right there, for every 1 mole PbI2, and for every 1 mole PbI2, I have this number I wrote down before, 461.01 grams PbI2. All right, then I do the math, and I've already done this, and it turns out that the mass here is 34.6 grams. All right, so that's the mass of my precipitate. Next, what is the concentration of each ion still in solution? All right, so if you think about it, we have 4 ions present. We have I minus, we have Na plus, we have NO3 minus, and then we have Pb plus 2. All right, now I minus was in the precipitate right here, and it was in the limiting reactant, so we know that one has 0 molar concentration. And these two are my spectator ions, so the denominator, that's my total volume, 0.800 liters, 0.800 liters. And then I just take my initial moles from memory. We have 0.150 moles of this and 0.100 moles of that. When we do the math here, hopefully I have this also. All right, so for Na, I have that over 8. So I get 0.188 molar Na plus in my solution. You do this math, you get 0.25 molar NO3 minus in the solution. All right, then the last thing that we need to do is find Pb plus 2. So we know that we have our initial moles. Our initial moles of that is 0.100 moles. I should put a 0 right there, by the way. And then my used moles we'll find in a second. And I'm going to subtract these to find my final moles. All right, and then that number I'll divide by 0.800 to get my concentration. All right, so the last step we're going to do here is a picket fence again. So we're still going to start with our limiting reactant. Oh, whatever. Which was 0.150 moles NaI. And for it was the 2 moles NaI, I have 1 mole PbI2. For every 1 mole PbI2, I have 1 mole Pb plus 2. So I do this math and I end up, this equals 0.075 moles used up meaning that's how many moles will react with the amount of limiting reactant I have. So now I take that number and I put it here, 0.075 moles. All right, and the difference between that is 0.025 moles. I multiply or I divide this. Remember, that's my total volume, and anytime we find concentration, it has to be moles per liter. All right, when I do that math, I end up with the concentration of Pb plus 2 being equal to 0.0313 molar. All right, whatever. Just erase this line, and there we go. We've answered all parts of that question.